Hi everyone, I Dr. Komala, working as Associate Professor in the Department of ECE at SJBIT, would like to explain about the following contents in this video. This video covers the basic concepts of zener diode, the avalanche diode, the comparison between the zener and the avalanche diode, and the applications of zener diode, how a zener diode can work as voltage regulator circuit. So first of all, let us know what a zener diode is. Earlier, you learnt about the PN junction diode, the applications of PN junction diode, and when we compare a regular PN junction diode with a zener diode, the most important thing is a PN junction diode allows maximum current to flow in the forward condition, forward bias condition, whereas a zener diode is a condition which can operate only under reverse breakdown region. This is the main difference between a ordinary p-n junction diode and a zener diode. The second important difference between a p-n diode and a zener diode is a p-n junction diode consists of extrinsic semiconductor material is an extrinsic semiconductor which is moderately doped, but if we want to make the semiconductor material operate as a zener diode, it should be very highly doped. So, with this brief content, now I would like to explain about the zener diode. A zener diode is a very highly doped semiconductor diode which is specially designed to operate in reverse direction. In other words, I can also call the diode which is specially designed for optimizing the breakdown region is called a zener diode. The zener diode also consists of only two terminals. As it is a diode, it has only two terminals, the anode terminal and the cathode terminal. The symbolic representation of a PN diode is slightly different compared to a zener diode, where the symbolic representation of a PN diode is just a triangular with a line. But in zener diode, we can see that the cathode terminal is represented by the alpha character by the character Z. So next, coming for the working of a zener diode. As we know, a PN diode can operate under unbiased condition, the forward bias condition and the reverse bias condition. But a zener diode can operate under reverse bias condition. But still it exhibits its own character when there is no biasing applied for a zener diode. When there is no bias which is applied for a zener diode, the electrons remains in the valence band of the p-type material and there is no current flow through the diode. But whereas when when a reverse bias is applied across the diode, there is a supply voltage which is equal to zener voltage, and then the reverse current starts flowing in the diode and the zener diode starts conducting in the reverse bias direction. So the characteristics of a zener diode is very well understood by means of a graph or the way characteristics of a zener diode. So whenever a zener diode is connected in forward bias condition, it just behaves like an ordinary diode, that is a PN diode. But whereas the zener diode is connected under reverse voltage or is reverse bias, whenever the reverse voltage is applied across it, the reverse voltage rises beyond the predetermined rating and the zener breakdown occurs. Only after that the zener current flows or is the reverse current flows. So this is the VA characteristic of a zener diode, where we can see the zener diode behaves as an ordinary diode or the ordinary PN diode whenever it is under forward bias condition. But whereas when the zener diode is connected in reverse bias condition, the voltage breakdown, which is called as zener breakdown, and this is a constant reverse current or the reverse voltage which is available in the reverse breakdown region. That's why the zener diode is also called as zener is also called as breakdown voltage diode or as zener breakdown diode. So there are two different mechanisms in which the reverse bias of PN junction diode would operate. The first one is zener breakdown voltage and the second one is avalanche breakdown voltage. So zener breakdown. Whenever there is a very narrow depletion region in a zener diode, the electric field strength produced by the reverse bias voltage will be very high. So whenever the reverse bias voltage is very high, the high intensity electron field will cause the electrons to break away from their atoms, thus converting the depletion region from an insulating material into a conductor, due to which the reverse current is more in a zener, zener diode. And this is the effect called as ionization effect, which is called as zener breakdown, which usually occurs with zero bias voltage, which is less than 5 ohms. So always a zener diode will work under the voltage which is less than 5 ohms. So coming for this second type of breakdown, which is called as the avalanche breakdown. When the depletion region is too wide for a zener breakdown, the electrons in this reverse saturation current will have sufficient energy which causes the other electrons to break free. So whenever these electrons strike the atoms within the depletion region, it will result in a collision between the ions, which is termed as ionization by collision. So at this point of time, the electrons released will collide with other atoms to produce more free electrons in an avalanche effect, which is called as avalanche breakdown. And avalanche breakdown is a breakdown which is normally produced whenever the reverse voltage level is above 5 volts. So these are the two types of breakdowns which is available. One is the zener breakdown and the other one is avalanche breakdown. Now coming for the comparison between the avalanche breakdown and the zener breakdown in brief. The zener breakdown occurs in PN junction diodes because of their narrow depletion region. But whereas an avalanche breakdown will occur in a PN junction diode because due to thick depletion layer. The second difference is the zener breakdown will usually occur when there is a high reverse voltage applied across the diode. In the same way, avalanche breakdown will also occur only when a high reverse voltage is applied across the diode. But whenever the voltage applied to a zener diode reaches to the point of zener voltage, the electric field becomes strong enough to pull electrons from the valence band. But in an avalanche diode, whenever the applied voltage increases, the electric field exerts a force on the electrons and frees them to form a covalent bond. So in zener breakdown, it creates the valence band, but whereas in a avalanche breakdown, it forms a covalent bond. One more major difference between the zener breakdown and the avalanche breakdown is the zener breakdown will occur when the reverse bias voltage is less than 5 volts, but whereas the avalanche breakdown will occur when the reverse bias voltage is greater than 5 volts. Next, coming for the symbolic or package representation of a zener breakdown, which was earlier explained. A zener breakdown, the symbol of a zener breakdown is, it consists of a triangle and a Z mark, where this is called as the anode terminal and this is called as the cathode terminal. Always normally it operates under reverse breakdown voltage. So for the operation of a zener diode, always it is operated in a reverse bias where the voltage drop is positive on the cathode and negative on the anode. This is how a zener diode can be connected in a circuit. The important characteristics of a zener diode are the zener breakdown voltage, the test current for measuring the zener voltage, the reverse current, the maximum zener current. So we can see that whenever a zener diode is connected in forward bias, it just behaves as a regular PN diode. It conducts in forward region, but whereas only whenever a zener diode is connected under reverse bias, it conducts at zero breakdown region. So there's a huge reverse current which is available in a zener breakdown or as in a zener diode. And always the maximum zener current will help in limiting by the maximum power dissipation in the diode. Next, the applications of zener diode. The zener diode finds various applications in electronic circuits. The three major applications that we come across in regular labs are devices are the zener diode can be used as voltage stabilizer. The zener diode can be used for meter protection. The zener diode can also be used for wave shaping. So here is the diagram of a multimeter, which enables us or which helps us to measure various parameters of an electronic circuits like voltage, current and resistance. So coming for the first application of zener diode, a zener diode can work as a voltage stabilizer because it provides constant voltage from the fluctuating voltage source to the load. So in the TV and fridge stabilizers, whichever we have, we make use of a zener diode so that there is no breakdown in the current whenever there is a negative reverse current which is available in the diode. There is a stabilization which is obtained in the voltage due to fluctuations. The second one application of a zener diode is for meter protection. The zener diode is normally used in multimeters, which helps for controlling the movement of the meter against the overloads. Whenever higher values are measured, higher values of current, voltage are measured, this protects the zener diode as in protection of the multimeter device. The third advantage of a zener diode is phase shaping. It is used for converting the sine wave into square wave, which can be done by placing two zener diodes in series with the resistance. So these are the three important applications of a zener diode. Further, we'll understand how a zener diode can be used as voltage regulator circuit. So to make the zener diode work as a voltage regulator circuit, what we do is we connect the zener diode in the reverse bias condition. This is a circuit how a zener diode can be used to regulate the voltage or the input power which is entering the circuit. This circuit, which is usually employed as a reference voltage reference source that supplies only a very low current to the output, and the resistor R1 will help in limiting the zener diode current up to the desired level. So how does a zener regulator circuit work with no load? It is one of the important applications of zener diode in which there is a DC voltage regulator circuit. So the zener diode, the zener current may be greater than the diode need current. So for most stable reference voltages, the zener current should be selected as the threshold current, which is demonstrated. So in this video, you have learnt about the different applications of zener diode and how zener diode can be used and how the zener diodes can be used for voltage regulation. In the same way, the zener diode can also be used as loaded regulator. So how to differentiate between a voltage regulator and a loaded regulator? Yes, when we connect a zener diode regulator which has supply a load current, then the total supply current should be the sum of the load current and the zener current. So we will take care such that there is minimum zener diode current which is large enough to keep the diode in reverse breakdown. So at this condition, all the current flows through the zener diode towards the load resistor, and when the load resistor is disconnected, the circuit design will be ensured so that the total current does not exceed the maximum zener diode current. So like this, we can also make use of a zener diode as a loaded regulator. The performance of a zener diode voltage regulator can be expressed in terms of source and load effects and the light and load regulations. And always the ripple rejection ratio of a regulator, voltage regulator, is important, which is the ratio of the output to the input ripple amplitudes. So the simple equation to calculate this is delta V naught is equal to delta ES into ZZ divided by R1 plus ZZ. So a zener diode can also work as a voltage regulator. So the main important advantage of a zener diode is it is used for voltage regulation, which is helpful and which is very much essential for most of the devices. So when we compare a regular PN junction diode or as an ordinary PN junction diode with a zener diode, whenever the forward current or the diodes operate in forward bias condition, we make use of a PN diode, and whenever we want the circuits to be operating under reverse current, we make use of a zener diode. So there are various types of diodes in which the zener diodes plays a major role in getting this regulation. Thank you.